Our first example question for segments from secants asks us to find the value of x, which is this missing segment right here, this chord that runs across the inside of our circle from point to point right here. And we're going to use our theorem, which says that a times a plus b is equal to c times c plus d. So that tells us that 18 times 18 plus x would be equal to 16 times 16 plus 24. So that tells us that we have 324 plus 18x, which would be equal to 16 times 16, which is 256, plus 16 times 24, which is 384. So if we then subtract 324 from both sides, we get 18x is equal to 316, and then divide both sides by 18. We get x equals about 17 and a half, 17 and 5/9. So about 17 and a half is how long x would be based on these other measurements. All right, let's take a look at example B. Example B again says find the value of x. Now this one's similar, not quite the same. We have two segments here that we don't know. So we're going to have x times x plus x, and that'll be equal to, now we have the whole length here all in one shot, and we have just the short length. So that's actually more convenient because we're not actually doing the additional addition. So we have 9 times a plus, or c plus d, which of course is the whole thing, so it's just 32. So that tells us that we have, if we add these two x's here together, we have 2x, and then multiply that by x again, that gives us 2x squared, and that's equal to 288. 9 times 32. Divide both sides by 2, and we'll get x squared is equal to 144. Well, if x squared is 144, then we can take the square root of both sides, and we get x is plus or minus 12, because whether it's positive 12 squared, it's 144, or negative 12 squared, it's 144. So x would have to be positive or negative 12. Now, obviously, since these lengths can't be negative lengths, they'd be non-existent, we know that the negative value wouldn't work. So our value for x is 12, and both of these lengths are going to be the same. Yeah? All right, and then example C. Example C is just a true-false question. It says, true or false, two secants will always intersect outside of a circle. Well, perhaps at first blush that might seem like that's the case, because if we have a circle, no matter where we draw these two lines, like so, it seems like they're always going to run into each other. However, there are a couple of possibilities that don't work that way. One would be if we had the two lines actually parallel to each other, which would mean they would be secant lines, but they wouldn't actually intersect anywhere, because parallel lines never do. And then the other possibility would be that perhaps we had, wow, that was a horrible circle. Perhaps we have two secant lines that intersect within the circle, like so. So obviously those wouldn't intersect outside the circle. If they intersect this way, they're just going to get farther and farther apart on the other end. So definitely false.